Good day, my name is Patrick. I'm here to talk on the topic work, energy, and power. But before I proceed, please don't forget to like, share, and subscribe on our YouTube channel at Scholars Card TV. All right, now work, energy, and power. Let me first of all talk about work. Work. Now, what we mean by work? When we move a distance, we have done work. When you carry something and walk a distance, I have done a work. What does it mean? Now it means that work can be defined as the product of force and its perpendicular distance. Are you getting it? Work can be defined as the product of force and its perpendicular distance. Its perpendicular distance. Perpendicular distance. Are you okay? All right. Product of force and its perpendicular distance. That is work. Are you getting it? It means that when I lift up a load or when I carry an object and move a distance, which means I have done work. Are you getting it? Good. That is the meaning of work. Now, what is the unit of work? The unit of work is joules. Are you getting it? The unit of work is joule. It's the same thing as energy, as we have been talking about previously. Now, work is a scalar quantity because it does not have direction. Are you getting it? It only has magnitude. Are you with me? That is that. So the formula we can say work done here, work done by a body or by an object will equal to force. The product of the force times distance, perpendicular distance, full stop. Are you with me? Good. Force times distance. That's the formula for work. Now also note that we have horizontal work done. Now, when a car starts from initial point at rest to another point, another horizontal reference point, which means that is horizontal work done. Are you getting it? Also, we also have gravitational work done. Are you with me? We also have gravitational work done. For example, when I lift a load from down to up, which means I have done work against gravity. Because we said whatever that goes up must surely comes down. Are you with me? So whenever you lift a load or carry something from up down, you have done work against gravity. Or for example, I would say a boy climbed a staircase, 2 steps, 2 distance, which means we have done work. The girl have done work against gravity. Are you with me? Which means we have gravitational work done as the work done against the gravitational influence of the earth. Are you get? So we can define gravitational work done as the work done against the gravitational influence of the earth. Are you with me? So we can say gravitational work done here, which we have a mass of the body, which is m, mass, times acceleration due to gravity times the height, mgh. You are looking at that, look at the potential energy, of course, because it's also work is done against gravity. Are you with me? Thank you very much. Thank you very much. Now let's look at a question here. We can take a question here to verify our explanation. We have a question here which says a constant force of 40 Newton acting on a body initially at rest gives it an acceleration of 0.1 meter per second square for 4 seconds. We now say calculate the work done by the body, by the force. Calculate the work done by the force. When you look at this question, let me clean here. When we look at this question here, we have the force. You write out the parameter. Are you getting it? You write out the parameter here. We have force here. Force F as 40 Newton. 40 Newton. Acting on a body initially at rest. Now, what we mean by a body is at rest, according to motion. When a body is at rest, that means that body is not moving, which means its initial velocity is 0. Whatever object or body that is not moving, its initial velocity is regarded as what? 0, which means since the body from the equation is at rest, u is equal to 0. U means initial velocity. Are you getting it? Good. Now, it gives an acceleration of 0.1 meter per second square. Acceleration here, A, equals to 0.1 meter per second square. Please don't forget to write the unit. It's very, very important. Are you getting it? For 4 seconds, time, we are given time equals to 4 seconds. Now, we have to calculate the work done by the force. Work done, we use W to represent work done by the force. Now, you are written out the parameters. Are you with me? God bless you. Now, we can now apply the formula. We say work done equals to force times distance. Let me use S to represent distance. Force times distance here. But when you look at it here, we don't have distance. Are you getting it? So we must look for a solution to find distance based on the parameters given to us here. Are you with me? Good. Now, we have here initial velocity, acceleration, time. So we go back to equation of motion, second equation of motion. Are you getting it? Now, the second equation of motion says distance s equals to ut plus half at squared. This is the second equation of motion, uniformly accelerated motion. Are you with me? Good. Where s stands for distance, u stands for initial velocity, t stands for time, a acceleration, and t. Now, when you look at it, we have all the parameters here given to us here. We now say, therefore, distance here will equals to u. Our u here is given as 0, multiplied by the time, 4, plus half, time, our acceleration here is 0.1, times the time, which is 4 seconds, 4 square. So we have t square here, don't forget. Good. Now we can now, this is now mathematics. We can now solve our mathematics to get the distance. Are you with me? Now look at the budget. Now distance s equal, now 0 times 4 is gone, 0 plus, now 4 square, which means 4 times 4, which is 16. Now 0.1 times 16 will give you 1.6. 1.6. Are you getting it? Now half for this half, this 1 over 2 means half. Half of 1.6, this now will give you 0 plus half of 1.6 gives 0.8. Are you with me? We use your calculator to verify it. Now, yeah, this now will now be equals to what? 0. Will give you 0.8 meter. Don't forget to put the unit. It's very important. You get that? Now we have gotten our distance here. Are you getting it? Since we have gotten our distance, you can now substitute it into the formula for work done. Therefore, our work done here, W will be equals to force. Our force is 40 Newton times the distance which I have calculated, 0.88 meter. So everything here, when you use our calculator to check it, it gives you 32 joules. 32 joules, which is our unit for work. I hope I've explained to your understanding. Thank you very much. Now, please, viewers, if you have any comments to share, to like, and subscribe to our YouTube channels at Scholars Card TV. Thank you.